Okay, good people. Let us try to look at the gradient at a point since we have talked about the average gradient. And once again, I must remind you, I'm just touching on very important concepts. Some of the things we will talk about when we come back. The gradient of a point. Uh, Let me once again go back to this sketch. You remember I talked about, I will take a very simple example of f of x equals x squared. We know that the derivative for this function f of x equals x squared, f prime x will be equal to 2x. Now let me show you what do I mean if I say uh, and this is the gradient and the gradient is dependent on x. What must I do if I want to calculate the gradient? Maybe at x is equal to 2, maybe at x is equal to 3, maybe at x is equal to negative 3. Surely you will remember that the gradient at this point will not be the same as the gradient at that point and also the gradient at that other point. So another concept that I need to bring in is that if I want to know the gradient at this point, another way would be to draw a tangent that passes through that point. Yabo mangadwebi tangent edlula la at this point. If ungakwazi ukukhalculate i-gradient at a tangent, ungakwazi ukuthola i-gradient of a curve at this point. Or rather, let me do a bigger sketch. Let me do a bigger sketch. I will take it like this. The gradient, say there's a tangent which touches the curve at this point. The tangent is the straight line. The gradient of the straight line does not change. It is the same everywhere. So at the point where the tangent touches the curve, the gradient of a straight line will be equal to the gradient of the curve at that point. At this point, you can see which gradient and tangent surely will not be the same as that one. So since the tangent is much or more steeper than this one, their gradients will not be the same. As I move along the tangent, the gradient is not going to change. So the time the tangent touches the curve, the gradient of the tangent will still be the same, which means that the gradient of the curve at this point will also be equal to the gradient of the tangent at this point. So you can see, say for an example, for this tangent, gradient is equal to 1. Maybe for this tangent, gradient is equal to 3. So you see that the gradient of the curve at this point will be equal to 1. The gradient of the curve at this point will be equal to 3. So why does it change? Because the gradient of the tangent, the gradient of the curve changes as you move along the curve. And it also depends on the x value here. Naliana foot, it depends on the x value there. You can see which this x value is not the same as that one. So the two at these 2 points, the gradient of the curve will not be the same. So what are we trying to say actually in terms of this? We are saying at this point, the gradient is not the same as that point. So now, how do I calculate the gradient at this point now at x is equal to 2? Please be very careful about this, good people. If f prime x is equal to 2x, then a gradient at x is equal to 2 will be f prime 2. F prime 2 is the gradient at x is equal to 2. Or rather, I should say at x is equal to 2, the gradient is equal to f prime 2. F prime 2 simply means go to f prime x, substitute x by 2. This is f prime x. Therefore, f prime 2 will be 2 times 2, which is equal to 4. Therefore, the gradient at this point is 4. So what about at x is equal to 3? At x is equal to 3, the gradient will be equal to f prime 3, which is 2 multiplied by 3. Remember f prime 3, you go to f prime x, you substitute x by 3, which is equal to 6. Now, at x is equal to 2, the gradient is 4. At x is equal to 3, the gradient is equal to 6. What about at x is equal to negative 3? At x is equal to negative 3, m will be equal to, or a gradient will be equal to f prime negative 3, which is 2 multiplied by negative 3, which is equal to negative 6. So surely you can see that if you could draw a tangent passing through that point, it would have a negative gradient. Let me break the video. See you once again after this.